Question and answer bank for exploration. Entering the world of secondary science. Multiple choice questions. Multiple choice questions. 1. What is the main difference between science in the middle stage and the secondary stage? A. The secondary stage uses no experiments. B. The secondary stage explores ideas with much greater depth, measuring, modeling, and testing. C. The secondary stage only memorizes facts. D. There is no difference. Answer. B. The secondary stage explores ideas with much greater depth, measuring, modeling, and testing. 2. Science is not only about what we know, but about blank. A. Who discovered it? B. How we know it? C. When it was discovered? D. Where it is taught? Answer. B. How we know it. Understanding how we know lets us judge new claims for ourselves. 3. Turning "it looks hot" into "it is 80 degrees Celsius" is an example of moving from A. Measurement to observation. B. Opinion to feeling. C. Observation to measurement. D. Symbol to pattern. Answer. C. Observation to measurement. 4. Why do scientists write patterns as symbols and equations, like V equals D divided by T? A. To make science harder. B. So patterns can be shared and tested precisely across the world. C. To hide the meaning. D. Because words are not allowed. Answer. B. So patterns can be shared and tested precisely across the world. 5. On every page of the textbook, the page number is framed by A. A star and a moon. B. A magnifying glass and a compass. C. An atom and a cell. D. A ruler and a clock. Answer. B. B. A magnifying glass and a compass. 6. The magnifying glass on each page stands for A. Direction and limits. B. Careful observation. C. Memorizing facts. D. Doing calculations. Answer. B. B. Careful observation. 7. The compass on each page stands for A. Careful observation. B. Direction, right models, right questions, and knowing limits. C. Measuring temperature. D. Aimless wandering. Answer. B. Direction, right models, right questions, and knowing limits. 8. In physics, a moving car can be modeled as A. A hot gas. B. A single point. C. A sphere with bonds. D. A smooth sphere with layers. Answer. B. B. A single point. 9. A model is best described as A. An exact copy of the real world. B. A simplified way of looking at a real system that keeps only what matters. C. A guess with no evidence. D. A list of every detail. Answer B. A simplified way of looking at a real system that keeps only what matters. 10. In the cricket 6 example, example 1.1, which of these matters for the model? A. The colour of the ball. B. The brand of the bat. C. The mass of the ball and the speed and direction of the hit. D. The amount of grass on the field. Answer C. The mass of the ball and the speed and direction of the hit. 11. Meghnad Saha studied the light from stars by treating the matter in a star as A. A solid ball. B. A hot gas. C. Millions of separate atoms modelled individually. D. A liquid. Answer B. A hot gas. 12. Saha's simplified model connected a stars to its A. Size, age. B. Color, temperature. C. Mass, distance. D. Brightness, name. Answer B. Color, temperature. 13. The symbol C for the speed of light comes from the Latin word celeritas, meaning A. Light. B. Speed. C. Constant. D. Clear. Answer B. Speed. 14. The exact defined value of the speed of light is A. 300,000 meters per second. B. 299,792,458 meters per second. C. 186,000 meters per second. D. 3 times 10 to 6 meters per second. Answer B. 299,792,458 meters per second. 15. The aircraft fuel disaster happened because the crew used density in A. Kilograms per litre instead of pounds per litre. B. Pounds per litre instead of kilograms per litre. C. Litres instead of kilograms. D. Grams instead of kilograms. Answer B. Pounds per litre instead of kilograms per litre. 16. A law in science. A. Explains why a pattern happens. B. Describes a regular pattern in nature. C. Is a broad idea applied across many situations. D. Is an untested guess. Answer B. Describes a regular pattern in nature. 17. A theory in science. A. Describes what happens but not why. B. Explains why a pattern happens based on evidence. C. Is just a wild guess. D. Can never be changed. Answer B. Explains why a pattern happens based on evidence. 18. Which is the best example of a principle? A. Newton's laws. B. Atomic theory. C. Conservation of energy. D. V equals D divided by T. Answer C. Conservation of energy. 19. In science, saying it's just a theory is wrong because a theory is A. An untested idea. B. An explanation built on careful testing and evidence. C. Weaker than a guess. D. Always final and unchangeable. Answer B. An explanation built on careful testing and evidence. 20. When a prediction does not match observation, scientists A. Ignore it. B. Re-examine their assumptions, models, or measurements. C. Call it a failure and give up. D. Change the evidence to fit. Answer B. B. Re-examine their assumptions, models, or measurements. Fill in the blanks. The journey of science began with and grew through careful experiments. Wonder. A measurement turns a vague impression into something that anyone can check. Exact. The real world is too complicated to study all at once, so we make a model. A good model is like a it helps precisely because it leaves things out. Map. In chemistry, atoms and molecules are drawn as joined by bonds. Spheres, balls. Building a model means making and deliberately ignoring certain details. Assumptions. When studying a falling object, we may ignore to see the basic effect of gravity. Air resistance. Scientists treated the matter in a star as a hot gas. Meghnad Saha. Quantities like mass, velocity, force, and current are written as m, v, f, and I. An equation is not just a calculation tool, it is a compact about how things are related. Statement. A means the same thing everywhere because measurements use agreed international standards. Kilogram. A describes what happens while a explains why. Law, theory. Using standard units everywhere removes a whole class of dangerous conversion errors. SI. A scientific prediction is an expectation, not a guess. Reasoned. Physics, chemistry, biology, and earth science are divisions made only to organize knowledge. Human-made. True or false? A scientific idea can never be thrown away, no matter the evidence. False. A model deliberately leaves out details that don't affect the answer. True. Leaving out a detail is a mistake only if it changes the answer. True. In everyday speech, words like force and work mean exactly what they mean in science. False. A symbol and its unit always travel together. A number without a unit is meaningless. True. In science, a theory is just an untested guess. False. Even very successful theories can fail in new conditions or with more precise measurements. True. Weather forecasts 3 weeks ahead are just as reliable as forecasts for tomorrow. False. A mismatch between prediction and observation is a useful clue, not just a failure. True. Food becomes harmful during an eclipse, passes scientific testing. False. D. Assertion reason. For each, choose A. Both correct. Reason explains assertion. B. Both correct. Reason does not explain assertion. C. Assertion correct. Reason wrong. D. Assertion wrong. Reason correct. 1. Assertion. A model leaves out many real details. Reason. Leaving out the right details makes a problem simple enough to solve while still answering the question. Answer. A. Both correct. Reason explains assertion. 2. Assertion. Science is reliable because it can be corrected. Reason. Scientific ideas stay open to improvement when better evidence appears. Answer. A. Both correct. Reason explains assertion. 3. Assertion. A kilogram means the same everywhere. Reason. Measurements use agreed international standards rather than local objects or opinions. Answer. A. Both correct. Reason explains assertion. 4. Assertion. A scientific prediction is the same as a guess. Reason. Predictions are reasoned expectations based on evidence and careful thinking. Answer. D. Assertion wrong, reason correct. The big shift is this. Science is not only about what we know, but about how we know it. This year, we trace the path from a question to a trusted answer through observation, measurement, modeling, and testing.